What's up, guys? This is Brad with Retire with Crypto, and today we're going to do a deep dive on Cosmos, probably the most underrated cryptocurrency on the planet. Cosmos is $18.13 right now, got a market cap of $4.3 billion, and it is the 19th ranked crypto. So, I guess it's not the most underrated ever. It's seen some great price action. Finally broke out in the bull run. It's been as high as $26. And now it's 18. So I think it's a great time to buy it. But I don't think people understand what Cosmos is doing. And it's really, really groundbreaking. And we really need to shine light on Cosmos. So I'm going to try my best to explain what they're doing. It's pretty complex. But I'm going to break it down in a humble way so that people like me can understand it. So Cosmos is a decentralized network of independent parallel blockchains, each powered by BFT consensus algorithms like the Tendermint consensus. BFT is Byzantine fault tolerance. What that means is on these blockchains, up to a third of the people on the blockchain can be giving false information and the blockchain will still function. That's what Byzantine fault basically just means, people that are fucking with you. They're giving you bad information. It's not working. They're trying to manipulate things. These blockchains can operate with up to a third of people giving them messed up and bad information. So that's pretty cool. Before Cosmos, all blockchains were siloed and unable to communicate with each other. So the first network that tried to solve that was Ethereum. And Ethereum came onto the chain with a new proposition for building decentralized applications. There'd be a single blockchain where people would be able to deploy any kind of program. Ethereum achieved this by turning the application layer into a virtual machine called the Ethereum virtual machine. The only problem is that there's scalability issues. It's a proof of work algorithm. It's slow, it's expensive, and there's limited sovereignty, big problems, and Cosmos has set out to solve those problems. Their vision is to become the Internet of blockchains, a network of blockchains able to communicate with each other in a decentralized way. So they've basically made it easy to deploy. They've laid all the groundwork to do the same thing as like building an Ethereum token. So they built the Tendermint BFT and the ABCI. Tendermint BFT is a solution that packages the networking and consensus layers of a blockchain into a generic engine, allowing developers to focus on application development as opposed to complex underlying protocol. So basically, the Tendermint BFT engine is connected to an application by a socket protocol called the Application Blockchain Interface. This protocol can be wrapped into any program language, making it possible for developers to choose a language that fits their needs. So basically, they do all the heavy lifting for you, and you just have to code your dApp and plug it into their basic blockchain programming. So instead of having to code for a year, you can code for 2 weeks and get your blockchain up and going. So the properties that make up a Tendermint BFT state-of-the-art blockchain engine are they're public or private blockchain ready. So Tendermint BFT only handles networking and consensus for a blockchain, meaning that it helps nodes propagate transactions and validators agree on a set of transactions to append to the blockchain. It is a role of the application layer to define how the validator set is constituted. Developers can therefore build both public and private blockchains on top of the Tendermint BFT engine. If the application defines that validators are elected based on how many tokens they have at stake, then their blockchain can be characterized as proof of stake. If, however, the application defines that only a restricted set of pre-authorized entities can be validators, then the blockchain can be characterized as permissioned or private. Developers have the freedom to customize the rules and define how the validator set of their blockchain changes. Tendermint BFT can have the block time of 1 second to handle up to thousands of transactions per second. The property of Tendermint consensus algorithm is instant finality. This means that forks are never created as long as more than 1/3 of the validators are honest. Users can be sure their transactions are finalized as soon as their block is created, which is not the case in proof of work blockchains like Bitcoin and Ethereum. Tendermint consensus is not only fault tolerant, it's also cannibal. If the blockchain forks, there's a way to determine liability. So then you've got the Cosmos SDK and other application layer frameworks. So the Cosmos SDK is a generalized framework that simplifies the process of building secure blockchain applications on top of Tendermint BFT. It's based on two major principles. Modularity. The goal of Cosmos SDK is to create a system of modules that allows developers to easily spin up application-specific blockchains without having to code functionality of their application from scratch. Anyone can create a module for Cosmos SDK, and using ready-built modules in your blockchain is as simple as importing them into your application. For example, the Tendermint team is building a set of basic modules that are needed for the Cosmos hubs. These modules can be used by any developer as they build their own application. Additionally, developers can create new modules to customize their application. As the Cosmos network develops, the ecosystem of SDK modules will expand, making it increasingly easier to develop complex blockchain applications. And then capabilities-based security. Capabilities constrain the security boundaries between modules, enabling developers to better reason about the composability of modules and limit the scope of malicious or unexpected interactions. For a deeper look at capabilities, click here. So let's break it down. Cosmos is basically doing 95% of the work. All you got to do is show up, code your app, and load their preset stuff into your blockchain, and you're good to go. Like, a lot of people are going to be building on Cosmos soon the way that they're building on Ethereum, and it solves the scaling issues of Ethereum and is interoperable with other blockchains. So let's go over Ethermint. The great thing about Cosmos SDK is that modularity allows developers to port virtually any existing blockchain code base already in the Golang on top of it. For example, Ethermint is a project that ports the Ethereum virtual machine into an SDK module. Ethermint works exactly like Ethereum, but also benefits from the properties of Tendermint BFT. All the existing Ethereum tools, Truffle, MetaMask, etc., are compatible with Ethermint, and you can port your smart contracts over without any additional work. So basically, anyone that's an ERC20 token or a dApp on Ethereum can just cut and paste right into Cosmos. So why bother creating a blockchain with the Cosmos SDK when I can just deploy my decentralized application on top of a virtual machine blockchain? So basically, why Cosmos and not Ethereum? So the question is justified considering that most decentralized apps today are developed on top of virtual machine blockchains like Ethereum. First, it should be stated that the reason for this phenomenon is that up until now, blockchains were much more difficult to develop than smart contracts. This is not the case anymore thanks to Cosmos SDK. Now developers can easily develop an entire application-specific blockchains, which have several advantages. Among others, they give more flexibility, security, performance, and sovereignty. To learn more about application-specific blockchains, read this post. Of course, if you don't want to build your own blockchain, you can still make smart contracts compatible with Cosmos by deploying them on Ethermint. So basically, they're giving every ERC20 application the opportunity to be their own blockchain. So, every Aave can also have its own blockchain. It doesn't have to deal with Ethereum scaling issues or gas fees or anything. They can be their own blockchain. This is freaking insane. It's huge, and I have no idea why people don't know about this. So, and here's the kicker. So now that developers have a way to quickly build customized blockchains. Let's see how to connect these blockchains together. The connection between blockchains is achieved through a protocol called the Inter-Blockchain Communication Protocol. IBC leverages the instant finality property of tendermint consensus to allow heterogeneous chains to transfer value, i.e. tokens or data, to each other. What are heterogeneous chains? Essentially, it comes down to two things. Different layers. Heterogeneous chains have different layers, meaning they can differ in how they implement networking, consensus, and application parts. To be compatible with IBC, a blockchain needs only follow a few requirements. The main one being that the consensus layer must have fast finality. Proof of work chains like Bitcoin and Ethereum do not fall into this category as they have probabilistic finality. Every blockchain is maintained by a set of validators whose job is to agree on the next block to commit to the blockchain. In proof of work blockchains, these validators are called miners. A sovereign blockchain is a blockchain with its own validator set. In many instances, it is important blockchains to be sovereign, as validators are ultimately responsible for modifying the state. In Ethereum, applications are run by a common set of validators. Because of this, each application has limited sovereignty. IBC allows heterogeneous blockchains to transfer tokens and data to each other, meaning that the blockchains with different applications and validator sets are interoperable. So all of your proof of stake blockchains or your instant settlement blockchains can communicate with each other through Cosmos. So this is how currently no other blockchain framework enables this level of interoperability. So they let you build dApps on it that have their own blockchain, and they make it interconnectable. Why is this not the number 3, number 4, number 5 coin? I have no idea. So the principle besides IBC is fairly simple. Let's take an example where an account on chain A wants to send us 10 tokens. Let's call them Atom to chain B. So continuously, chain B receives the headers of chain A and vice versa. This allows each chain to track the validator set of the other. In essence, each chain runs a light client of the other. When IBC is initiated, the Atom are locked up, bonded on chain A. Then the proof that the 10 Atom are bonded is relayed from chain A to chain B. The proof is validated on chain B against chain A's header, and if it's not valid, then the 10 Atom vouchers are created. And then if it is valid, then 10 Atom vouchers are created on chain B. Note that the Atom have been created on chain B are not real Atom, as Atom can only exist on chain A. They're a representation on B of Atom from chain A, along with proof that these Atom are frozen on chain A. A similar mechanism is used to unlock Atom when they come back to their origin chain. For a more comprehensive description of IBC protocol, you can look at this specification. So they're designing the internet of blockchains. And I mean, it's just freaking, they're doing so much. Let's continue reading. So IBC is a protocol that allows two heterogeneous blockchains to transfer tokens to each other. From there, how do we create a network of blockchains? One idea is to connect each blockchain in the network with every other via direct IBC connections. The main problem with this approach is the number of connections in the network grows quadratically with the number of blockchains. If there are 100 blockchains in the network and each needs to maintain an IBC connection with each other, that's 4950 connections. This quickly gets out of hand. To solve this, Cosmos proposes a modular architecture with two classes of blockchains, hubs and zones. Zones are regular heterogeneous blockchains, and hubs are blockchains that are designed to connect zones together. When a zone creates an IBC connection along the hub or with a hub, it can automatically access, i.e. send and receive from every other zone that it's connected to. As a result, the zone only needs to establish a limited number of connections with a restricted set of hubs. Hubs also prevent double spending among zones. This means that when a zone receives a token from a hub, it only needs to trust the origin zone of this token and the hub. The first hub launched in the Cosmos network is the Cosmos Hub. The Cosmos Hub is a proof-of-stake blockchain whose native token staking is called Atom, where transaction fees are payable in multiple tokens. The launch of the hub also marks the launch of the Cosmos network. And then bridging non-tendermint chains. So far, the architecture of Cosmos we have presented shows how tendermint-based chains can interoperate, but Cosmos is not limited to tendermint chains. In fact, any kind of blockchain can be connected to Cosmos. We have two cases to distinguish: fast finality and probabilistic finality. So proof of stake, proof of work. Fast finality: blockchains that use any fast finality consensus algorithms can connect with Cosmos by adapting IBC. For example, if Ethereum were to switch to Casper FFG, friendly finality gadget, a direct connection could be established between it and the Cosmos ecosystem by adapting IBC to work with Casper. So, proof of stake, proof of work. For blockchains that do not have fast finality, like proof of work chains, things get a little bit trickier. For these chains, we use a special kind of proxy called PegZone. PegZone is a blockchain that tracks the state of another blockchain. The PegZone itself has fast finality and therefore is compatible with IBC. Its role is to establish finality for the blockchain it bridges. Let's look at the following example. So this is the Ethereum PegZone. So we want to bridge the proof of work Ethereum blockchain to make it possible to send tokens back and forth between Ethereum and Cosmos. Because proof of work Ethereum does not have fast finality, we need to create a peg zone to act as a bridge between the two. First, the peg zone needs to decide on a finality threshold for the origin chain. For example, it can consider that a given block of the origins chain is final when 100 blocks have been added after it. Second, a contract is deployed on the main Ethereum blockchain. When users want to send tokens from Ethereum to Cosmos, they start by sending tokens to this contract. The contract freezes the assets, and after 100 blocks, a representation of these assets is released on the peg zone. A similar mechanism is used to send assets back to the Ethereum chain. Interestingly enough, the peg zone also allows users to send any token that lives on Cosmos to the Ethereum chain. The Cosmos tokens would be represented as ERC20 on the Ethereum chain. The Tendermint team is currently working on a peg zone implementation for the Ethereum chain called Peggy. Peg zones will need to be customized for the particular chain that they bridge. Building Ethereum peg zone is relatively simple because Ethereum is account-based and has smart contracts. However, building a Bitcoin peg zone is a bit more challenging. Explaining how to build a Bitcoin-like peg zone is out of scope for this intro, but know that it is theoretically possible. If you want to know more about peg zones, take a look at this spec. So this is getting super boring and super long, but as you can see, they're on top of it. I mean, they know what they're doing. So, and then how does it scale? So vertical scalability. This encompasses the methods for scaling the blockchain itself. By moving away from proof of work and optimizing its components, Tendermint BFT can reach thousands of transactions per second. The bottleneck factor is the application itself. For example, an application like a virtual machine, e.g. the Ethereum virtual machine, will impose a much lower limit on transaction throughput from an application where transaction types and state transaction functions are directly embedded in it, e.g. a standard Cosmos SDK application. This is one of the reasons why application-specific blockchains make sense. Horizontal scalability. Even if consensus engine and application are highly optimized, at some point the transaction throughput of a single chain inevitably hits a wall it cannot surpass. That is the limit of vertical scaling. To go beyond it, the solution is to move to multi-chain architectures. The idea is to have multiple parallel chains running the same application and operated by a common validator set, making blockchains theoretically infinitely scalable. Details about horizontal scalability are fairly complex and out of scope for this intro. So basically they can clone it and clone it and clone it and clone it and make as many blockchains as they want. So in the end, what is Cosmos? Hopefully by now you have a clearer picture of the Cosmos project. Here is a quick recap of what Cosmos is in 3 concise points. Cosmos makes blockchains powerful and easy to develop with Tendermint BFT and the modularity of the Cosmos SDK. Cosmos enables blockchains to transfer value with each other through IBC and PEG zones while letting them retain their sovereignty. Cosmos allows blockchain applications to scale millions of users through horizontal and vertical scalability. More than anything, Cosmos is not a product but an ecosystem built on modular, adaptable, and interchangeable tools. Developers are encouraged to join the effort to improve existing tools and create new ones in order to make the promise of blockchain technology a reality. These tools are the foundation needed to create the decentralized internet and global financial system of tomorrow. So basically, they're solving all of the problems that are on Ethereum. And they just launched this called Stargate, or this program called Stargate. And it's basically their last test net of the Cosmos hub. And it's being built now. Stargate is a set of upgrades that complete the original roadmap laid out in the Cosmos white paper. For the first time ever, Cosmos blockchains will be able to connect with each other using the first standardized protocol for inter-blockchain communication. So basically it went live, and this just happened. So all the things that they have been describing are able to be done now. So that's extremely, extremely, extremely bullish. I mean, everything that Polkadot is trying to do, everything that Cardano is trying to do, everything that Ethereum is trying to do, and all the problems with it, Cosmos does just as well, if not better. Definitely want to check out Cosmos. I'm going to start accumulating the shit out of Cosmos. I think it's a great coin and a great network, and I think the future will be built on Cosmos. So thanks for watching, guys. That's my deep dive. I did the best I could with my simple brain to explain this very complicated thing. I hope you guys have a better understanding of Cosmos now. Thanks for watching. Take care.